So now we're going to go over hypothesis testing, okay? It is another part of inferential statistics, okay? If you recall, Chapter 8 was the first thing we were doing with inferential statistics. We were finding confidence intervals. Confidence intervals allowed us to have a good estimate of where the population parameter would be. If you recall, we would get a test statistic and calculate some error, and we could be some percentage sure that the true population parameter would lie between some lower bound and some upper bound, okay? Now, hypothesis testing is going to allow us to test a claim made about a population parameter, okay? So we may say some population parameter is less than some number, okay? For instance, I could say that the average age of CLC students, here's my claim, the average age of CLC students is less than 22 years old. With the things found in this chapter, we're going to be able to test that claim, okay, by collecting data. All right. Now this chapter is going to flow a lot like Chapter 8. In 9.1, we're going to go through the ideas in parts of a hypothesis test. Just like in 8.1, we went through the parts and pieces of a confidence interval. And then 9.2 is going to be about the population mean when you know the population standard deviation. 9.3 is going to be the population mean when you don't know the population standard deviation. And then 9.4 is going to be about the proportion. Okay? So much like Chapter 8. All right, so let's see. Let's read through that first example. Let's see, it says, Acme makes fabric cleaner and claims that the product removes 90% of all stains. A consumer organization selects a random sample of 100 stained garments and applies the product to each garment and finds that the stain remover successfully cleans 78 of the stained garments. Does the sample data provide evidence that the success rate for the fabric cleaner is less than 90%? Okay, so let's pick through it real quick. Here's the claim right here. That the cleaner removes 90% of all stains. Now, when this consumer organization, they sampled 100 garments, 100 soiled garments or stained garments, and it cleaned 78 garments. Now, if I were to find the proportion of clean garments, 78 out of 100, 0.78 or 78%, does this claim hold up based on our data here? This is the kind of thing that we're going to be able to answer in this chapter. The company made a claim about their product, and of course they want to talk good about their product. They're going to want to be selling a bunch of it, okay? However, consumer organizations may be concerned that product could be lying, or companies could be lying, so they want to go ahead and test their products so if they could see if they're ripping off their customers, okay? All right, now, let's see, this. Now, hypothesis testing is going to have two contradictory hypotheses or claims, and then we're going to run through some numbers And based on those numbers, we're going to be able to make a decision about our claims, our hypotheses. And then from there, we're going to write up a conclusion stating everything that we found from our test. Now, this is a 5-step process. The first thing you need to do is set up 2 contradictory hypotheses. We're going to go through that. First thing we're going to go through, let's go through the steps first. The second thing is determine the correct sampling distribution. Okay? Now, if you recall, back in chapter 8, we had to see if it was a proportion, if the mean, if we knew the population standard deviation, or if we didn't. That determined what distribution we used. Okay? So, if you want to use the z distribution, you're always going to use the z distribution for proportions. And you use the z distribution for a population mean if you know the population standard deviation. Now, if you don't know the population standard deviation and you're doing a hypothesis test for the mean, you'll be using the t distribution. So it's the same idea as chapter 8. I even made a web diagram for you guys to help you figure out what distribution you should use. It's on Blackboard. It's in section, or it's in the chapter 8 folder for the lecture videos, I believe. So, or the lecture notes. Take a look there. Okay, now, we also need to state the level of significance. That's going to come from our confidence level. We will go over that. And along with the appropriate test. Now, to find the appropriate test, that relies on us setting up our hypotheses. It comes from one of our hypotheses. And then, based on our numbers, we're going to find the test statistic and the probability of the test statistic. Now, those are 2 methods. One's called the test statistic method. The other one's called the p-value method. We're not going to go through the test statistic method. We're only going to go through the p-value method. And it's going to be more on the calculator, okay? Where the first example I go through, we're going to show some things by hand to just show you the idea of the work involved. But then from then on, we're going to do everything on the calculator. And then after we find the p-value, we're going to use that number to make a decision about our hypotheses. And then we're going to interpret our decision and write it up into a meaningful conclusion. Okay, so that's the 5-step process. Now let's go through and talk about the details of the 5-step process. The first thing are the hypotheses. So the first one is the null hypothesis, or H naught. It's like a little circle down there, H naught. Now, anytime we do a hypothesis test, we're going to assume this is true. Now, our null hypothesis is going to be some statement about the population parameter. So, like my example for the average age of CLC students, I said the average age is less than 22 years old. Okay? So that would be my null hypothesis. It's a statement about a population parameter. The average age, the population average age of CLC students is less than 22 years old. Or in the previous example we had, it was a proportion. Okay? The claim was that the fabric cleaner removed 90%, we're going to say 90% or more, in this case, of all stains. Okay, so now, the alternative hypothesis. Well, that's H with a little a down there. Now, this is another statement about the population parameter, but this is running out of room. The alternative hypothesis is contradictory to H naught. Okay. Now, this is very important that they are contradictory of one another. They're complete opposites. That's what that's meaning. So if we're assuming this one is to be true, and we find out that our assumption was right, then this one has to be false because they are contradictory. Now, if I'm assuming this to be true, but then I go through, find out the numbers, tell me that I'm wrong, my assumption's wrong, and this one's actually false, or could be false, since they're opposites, then this one has to be true. Okay? So that's very important that they are contradictory of each other. Now, sometimes the alternative hypothesis is called the research hypothesis. Okay? Okay, now, since they are two the null hypothesis and the alternative hypothesis are contradictory to one another, only one of them could be true. So, based on your calculations, here are your decisions. So, these are your decisions. One is to reject the null hypothesis. Okay. So remember, we're assuming it to be true. From the very beginning, we assume that the null hypothesis is true. But then, based on our data, if we reject it, that just means that our initial assumption was wrong. The second decision that we could have is do not reject H naught. Do not reject H naught is not the same thing as accepting H naught. Remember, we assumed H naught to be true. Under our assumption, just because we assumed it to be true doesn't necessarily mean that it is true. We just don't have enough evidence to show that it is false. If we had enough evidence to show that it was false, we would reject it. But since we don't have enough evidence to show that it is false, we assume that it's true, okay? That doesn't make it actually true. So we do not reject does not mean the same thing as accepting. We are not accepting the null hypothesis. We're just not rejecting it. We're saying it's plausible. Okay? More testing could be done to figure out maybe we do reject it. Okay? Now, the decision will be clear later on which one to choose. There's clear criteria on when to choose this, when to choose this. Okay? We'll go over that when we get to a problem. Alright, so there's a little note. Null hypothesis will always have the equal sign. So that means greater than or equal to, less than or equal to, or actually equal to. Alt for alternative hypothesis, so you don't have to keep writing alternative every time. HYP, short alternative hypothesis. You could write this. I'm fine with this. If you write this on the test. We're actually just going to write H naught and HA. Alternative hypothesis Now these ones are always the less than, greater than, or not equal to. So these are contradictory to one another. These are contradictory to one another. These are contradictory to one another, right? If you're greater than or equal to, if you're greater than or equal to, the opposite of that is less than. If you're less than or equal to, the opposite of that is greater than. If you're equal to, the opposite of that is not equal to, okay? So those are contradictory statements. Now let's go through and see how to write our null hypothesis and our alternative hypothesis. And we've got some examples. So how we're going to do this, H naught colon HA colon. Just like that. We're going to write our statement here, write our statement there. So let's read it. It says, we wish to test the claim that more than 30% of all registered voters in a certain county voted in the primary election. Okay? They gave us a percentage. 30%. So that's P is equal to 0.3 or 0.30. They gave us a proportion, okay? Now, let's read it one more time. It says, we wish to test the claim that more than 30%, okay? I'm going to write it down here. Let's just write that statement and let's figure out where it goes. Now, the wording here is, you got to be very careful with the wording. It says, we wish to test the claim, so we're talking about proportions here, so our population, proportion, P, the claim that this is more than 30%, or 0.30. Look at the last note that I just gave you. On the wording, it says more than. If it said at least 30%, we would put an equal to sign here. But it just says more than. The proportion is more than 30%. That's why we do not put an equal to sign. It's just a greater than sign. No greater than or equal to. Now, where to put that? Here. If you look at that last note, it doesn't have an equal to sign. The alternative hypothesis always has the not equals to. Now you need to write the null hypothesis based on this one right here, okay? You just need a contradictory statement to this. So it's going to look the same, P 0.30 here. So this is greater than. This one has to have an equal to because the alternative hypothesis always has an equal to. Well, if this is greater than, the opposite of greater than should be less than. Now, recall that this is our claim. You got to remember which one is your claim because that's going to be very important when we write the conclusion, okay? We're going to learn how to write the conclusion when we go over problems. But it's still important to remember which one of these is your claim. Your claim is not always going to be your alternative. The claim could be the null. If I were to reword this problem to say at least, it would have an equal to sign and it would have been up there and our claim would have been the null hypothesis. Okay? Let's look at the next one. It says we want to test whether the mean GPA of students in American college is different from 2.0. Okay, we want to test whether the mean GPA is different from 2.0. Okay, so let's say that's our claim. It's different from 2.0. And it's the mean, so mean is different from just means it's not equal to. Alright, it's not saying more than or less than, it's just saying it's different from. And the same as would be equal to. So it's different from 2.0. It has the not equal to. The not equals to is always the alternative, so it goes here. So here's our claim. So the opposite of not equal to is equal to. And this is how you're going to start every problem. You're going to read the problem. You're going to write your null hypothesis. And you're going to write your alternative hypothesis. Okay? At the beginning of the problems, it should look just like this. Now on the test, it's going to be formatted nicely. I'm going to write like a nice H null here with this, and you just got to fill in the blank. Same with this, you got to fill in the blank. You got to identify which one is your claim, okay? It's going to be in the instructions, but you're going to have blanks to fill the spots in. Okay, let's look at the next one. We want to test whether the average time needed to complete a bachelor degree in the U.S. is less than or equal to 5 years. Okay? We want to test, so there's our claim. We want to test the average time needed to complete a bachelor's degree in the U.S. is less than or equal to. So mu is less than or equal to 5 years. It has the equal to sign, so it goes on the null. So now we got a mu, we got a 5 here. This doesn't have the equal to sign. The opposite of a less than should be a greater than. This is an example where here's the claim. Now another way you could have said this is at most 5. So at most 5, it would have meant the same thing, okay? Again, you got to read it very carefully and think of which inequality signs you are going to use, okay?